In math, we use written lists to communicate sets of items, which we call set notation. In this video, we'll learn how set notation works and how some sets can be condensed by using interval notation. Let's start by looking at set notation. If you go to an ice cream shop and ask the clerk which flavors they have, there's a chance there will be so many flavors that they simply refer you to the posted menu. Or when you go grocery shopping, you probably know how helpful it is to have your shopping lists written down. These are both examples of how we use written lists to communicate sets of items. In math, we represent collections of items called sets by separating those items with a comma and enclosing the set in curly brackets. For example, the set apples, bananas, and oranges can be written using the following mathematical notation. More commonly in math, though, the sets we wish to represent are collections of numbers. For example, the set of numbers appearing on the analog clock can be written like this. Similarly, for a 5-question quiz, we can write the set of possible scores in this way. We could even write sets that contain hundreds or even thousands of numbers, though this would take a long time and be quite tedious. Let's consider an example in the world of statistics. When we talk about probabilities, we mean the chance of something specific occurring. These probabilities are usually represented as percentages, or equivalently as decimal values between 0 and 1. Let's write all possible probabilities as a set, every number between 0 and 1. Of course, we start with 0, and then we can add all of the tenths place decimals and finish with 1. But there are more than just 9 real numbers between 0 and 1. There's also all the numbers with 2 decimal places, like 0.01 and 0.02. But once we add all of those, we also need to list all the numbers with 3 decimal places, like 0.001 and 0.002. And it keeps going on because there are infinitely many real numbers between 0 and 1. In fact, in any given continuous interval, there are infinitely many real numbers. So, how can we accurately and completely list such numbers? This is where interval notation comes in, and in fact, it can help us represent intervals of continuous real numbers in a matter of seconds. We can use interval notation to represent all real numbers from 0 to 1 like this. The left number, in this case 0, represents the lower bound of the continuous interval, and the number on the right, in this case 1, represents the upper bound of the continuous interval. The square brackets enclosing these numbers indicate that 0 and 1 are themselves included in the set. In this concise notation, we have listed all possible real numbers from 0 to 1. Let's use interval notation for another example. Suppose Gina is practicing her 100-meter dash and attempting to beat her personal record of 14.9 seconds. What is the set of all possible running times that are less than 14.9 seconds? In this example, we again want to consider all real numbers in the interval, this time from 0 to 14.9. Let's make 0 the lower bound. We write it in the left position, followed by a comma, and 14.9 in the right position as the upper bound. In the last example, we used square brackets on the left and on the right to indicate that both 0 and 1 were included in the set. This time, though, we don't want to include 0 because it's impossible to move across a distance if no time has passed. And we don't want to include 14.9 because Jana is trying to beat that time. To include all numbers between 0 and 14.9 but exclude 0 and 14.9 themselves, we simply use parentheses on the left and on the right. So, square brackets indicate that the upper or lower number is included in the set, while parentheses indicate that the upper or lower number is not included in the set. In some cases, one bound will be included while the other will not. This can be accomplished using a square bracket on one side and a parenthesis on the other side. For example, this interval notation represents the set of all real numbers from -5 to -3, including -5 but not including -3. We could represent this on the number line using a solid point at -5 and an open point at -3. Alternatively, we can represent this set using inequality symbols. X belongs to the set -5 to -3 if -5 is less than or equal to x is less than -3. Each of these notations accomplishes the same purpose of describing all real numbers between -5 and -3, including -5 but not including -3. Let's try one more example. Lance is training his pet turtle Skipper for a turtle race, in which competitors traverse the length of a 6-foot table. During the training, Lance observes that after 30 seconds pass, Skipper is not yet at the 6-foot mark. Use interval notation to describe all possible distances that Skipper could be from the end of the table in those 30 seconds. In this scenario, the minimum distance or lower bound is 0 feet, and the maximum distance or upper bound is 6 feet. Because of this, we will write 0 as the left number and 6 as the right number. We also know that Skipper the turtle did not make it all the way to 6 feet yet. This means that 6 itself cannot be included as part of the interval. We will write a parenthesis after the 6 to indicate its exclusion. 0, on the other hand, is a possibility. Skipper may not have moved at all in the 30 seconds. For this reason, we will write a square bracket beside the 0, indicating its inclusion. So, after 30 seconds, Lance's turtle is some distance in the interval 0 to 6 from the end of the table. We've seen that interval notation is a powerful tool that helps us express infinitely many numbers in just seconds. The main tricks to remember with interval notation are that 1, the lower bound is always written first, followed by a comma and then the upper bound. And 2, we use square brackets to indicate a number's inclusion in the set and parentheses to indicate a number's exclusion from the set. Some students find it helpful to remember the square brackets and parentheses this way. A square bracket is shaped sort of like a box, and a parenthesis is shaped somewhat like a bowl. If you drop a ball into a box, it will probably stay in the box. Just like square brackets indicate that a number stays in the set. On the other hand, a ball dropped into a bowl will probably slide out, just like how parentheses indicate that a number doesn't stay in the set. With that, I think you're ready for some independent practice. I hope this video was helpful. Thanks for watching and happy studying.